NCR-CRD webinar. We're excited to have you here, and looking out amongst the crowd, I see some old friends joining us today, so welcome, and some new friends as well. So we appreciate everyone taking the time to join us today. My name is Dr. Michael Wilcox. I'm the Associate Director of the North Central Regional Center for Rural Development, and we're joined by several of our team members today from the NCR-CRD, as well as some friends from Michigan State and Iowa State. So we'll get right to it. If we could have Armin share his slides, that would be great. Share his screen. Perfect. So today's webinar is going to be split into two parts. The overarching theme is incorporating AI into housing and community development. Armin Yeganay, a fellow with NCR-CRD, he is going to be presenting first. He's an assistant professor with the construction management program at Michigan State University. And Dr. Yeganay's research focuses on housing and real estate data analytics, as well as emerging technologies in the construction industry. Armin's work contributes to the development of smart and sustainable residential buildings and communities. Looking forward to that. And then part two is our friends from Iowa State exploring the potential role of AI in community development. And my good buddy Lisa Bates, the Assistant Director of the Community and Economic Development Extension Program at Iowa State University Extension and Outreach, is joining us. She's the Assistant Director, and she oversees the CED's unit data team and works with the team's data science experts to improve access and use understanding of data for better informed community decisions. And our colleague Chris Seeger is also joining us as well. He's PLA and GISP. He's the Morrill Professor and Extension Specialist in Landscape Architecture at Iowa State University Extension and Outreach. And as the director of the Indicators Program, Professor Seeger aims to provide community demographic, health, and economic data resources to the public and local decision makers. And then if we could move to the next slide, we always show the what's coming up next month. November's webinar is going to be Addressing Rural Mental Health in the North Central Region. It's a special two-part webinar in recognition of National Rural Health Day. That'll be Friday, November 22nd, 2024 from 2 to 3 p.m. Eastern Time. And we're going to have a presentation. It's in two parts again. The first is Supporting Youth Mental Health, an adult volunteer training program. It's going to be from the University of Wisconsin. And then part two is from South Dakota. It's a South Dakota needs assessment on farm stress and mental health. And they're going to be offering some preliminary findings associated with farm stress and mental health. So we've got a great program today, and we've got another great program coming up in November. So thanks again for joining us, and I'll hand things off to Dr. Yeganay.
Thank you, Michael. So my name is Armin Yeganay. I'm an assistant professor at Michigan State University. And over the last year, I worked on this fellowship at the NCR-CRD. And the topic was really, where are mobile home parks? The reason we started this project was that I felt the need to create a large data set of the locations and some physical characteristics of these affordable housing communities. And so I used some AI-driven methodologies to try to develop a way of detecting and mapping these communities across primarily the North Central region, and the methodology is applicable to pretty much any other state. So to give you some background about myself, I have a PhD in environmental design and planning from Virginia Tech. I also have master's degrees in building construction science and management, urban and regional planning, and architectural engineering. So at MSU, I teach a course on construction quantity surveying or cost estimating. I also teach data analytics and emerging technologies in real estate, where we work on data programming languages like R and Python. My research is focused on housing sustainability and technologies. I try to answer questions on innovative practices and policies that advance construction management, sustainable housing, and real estate development. My research methods of interest are multivariate regression analysis, machine learning and deep learning, image processing, cost-benefit analysis, and Monte Carlo simulation for risk and uncertainty analyses of investments. So to give you some background about these mobile home communities or manufactured housing communities, these are the largest source of unsubsidized affordable housing in the US, comprising around 6 to 7% of the American housing stock. But the problem we face is that there is limited research on manufactured housing communities, and so we feel that there is no systematically collected data set on count, footprint, location, or other characteristics of these communities. These are primarily treated as some kind of informal development or sometimes stigmatized, unfortunately, by local governments. So they don't really try to push this communities. So we felt that this is an area that we need to research. And this area is important because of its role as an affordable housing solution. It can encourage individuals to move to rural areas for job prospects and contribute to the local economy. And on the other side, if these are well managed, they can create a stable and cohesive communities, leading to community engagement and initiatives at local improvement. In this project, we aim to create the most comprehensive source of manufactured housing data and shapefiles of the North Central region. And I can claim that this is the first automatically created manufactured housing community data set and mapping solution in the US, which can be automatically updated for longitudinal analyses over the following years with minimal human involvement. And our research was focused on the 12 states in the North Central region, but again, the methodology can be applied to any other states. And a lot of different people can use our results, like developers, investors, governments, planners, researchers, environmental organizations. Like anyone that works with manufactured housing communities can benefit from the work that we did with at NCRCRD. So if you look at the aerial images of the housing stock, you can sort of distinguish between different types or typologies, like formal subdivisions, informal subdivisions, and single wide and double wide manufactured housing communities. And the double wides are primarily the single wide structures put together, as two units that are attached to each other just to give more space to the occupants. And the characteristics like density and the length to width ratio, um, these are the characteristics that can be detected by computer vision models. So the deep learning models and overall the AI can distinguish between different kinds of patterns, and that makes it easy for us to detect the locations of these communities. So we can also pre-process these images to simpler formats like black and white shapes. So structure can be detected versus the background, making it easier for the model to identify different types of housing communities. Overall, the process starts with delineating the region of interest, which is in this case the state of Indiana. And then we have to define small squares, as you saw in the previous slides. Those are the units of analyses. And the next step is to classify manufactured housing communities versus anything else that is non-manufactured housing community. And then once we have identified the exact locations, we just need to overlay the places that were identified as manufactured housing communities and then try to identify the community itself and then prepare the final data set. So starting this project, I focused on obtaining data from Google's aerial images. I found it a bit unaffordable because we had to obtain millions of images from each state, and it was kind of expensive. So another solution that I found was a leaf map, which is a very helpful package developed for Python. And it was kind of connected to Google servers, and it allowed us to extract aerial images without the need to use the paid version of the Google API, which was very helpful. And so we started by looking at latitude and longitudes, which are the geographical coordinates used to specify the locations of points on the Earth's surface. So latitude, as you know, is a measurement of the location north or south of the equator, and longitude, it ranges from 0 at the prime meridian. And the units of analysis is a tile. And this was developed based on just experimenting with the model for a few times to see which size is kind of roughly the size that the model can identify the best. And the tile has a height equivalent to 1,000th of a degree latitude. And then they had to work with some solutions and formulas to make sure that despite having the curvature of the land, like the Earth's surface is spherical, and then we had to use some formulas to make sure that the tiles that we are getting have width and height of identical actual sizes in terms of their measurements on the Earth, like in terms of meter or feet of width and height. So we did some calculations, and then the next step was to just define the bounding blocks of the states, which was in this case Indiana, and then we divided the state into millions of small tiles. So we downloaded each tile separately and then stored it in a folder and created different versions of each tile for different parts of the analyses. And so this is kind of how it looks like in my computer. So we just needed to identify which of these tiles are really mobile home parks and which are not. And then that helps us detect the position of these on the Earth's surface. So as you can see, this is a training set that we developed to say, okay, these ones are mobile home communities so that the AI model could understand which ones are referred to as manufactured housing communities. And then the other set was non-manufactured housing communities, like anything other than manufactured housing communities were labeled as a non-manufactured housing community image. And we developed some indicators. We used some indicators from the literature to measure the performance of different models. So there are pre-trained models developed by different organizations and companies like Microsoft, Google, researchers across the world. We tried many of them, and the MobileNet model seemed to be the most efficient in terms of the speed and accuracy to do this task. So each of these pre-trained models have different characteristics, like the neural network layers and other like technical characteristics that make them appropriate for a different kind of task. And so some of these processes that we perform were informed by experiments rather than direct knowledge. And once we identified the locations of manufactured housing communities, we just mapped them on the surface of the Earth. And this is kind of how it looks like when we're looking at the position of manufactured housing communities across the state of Indiana. And the next step was to focus on each communities and try to extract the footprints and the structures and delineate the boundaries and things like that. So we, again, experimented with different algorithms to see which one works best in terms of identifying the structure versus background versus shadow. So there are some models in Esri's ArcGIS Pro, and there are some other solutions developed by different researchers. So we tested some of these to see how we can identify the structures and how we can regulate the shape files so they look exactly square or rectangular shape. And the final stage was to remove the outliers. So once we detect the approximate characteristics of the community, like the one that is seen on the left side of this slide, we have to remove the outliers because some structures will be on the overall layout of the community. So this has to be either removed manually or using some automated version We decided to do this part manually because we had to look at the roads and the site boundaries and other natural features to have a sense of which of these are probably outliers and which of these are structures that belong to the community. And in some cases, the state files, the state governments make parcel maps available. And in those cases, we can simply join the parcel maps with whatever we have in terms of the detected locations. And then everything that falls outside the parcel is likely to be an outlier, a structure that doesn't belong. So in those cases where the parcel map is available, we can easily remove structures that don't belong to the park. But in terms of individual structures that are placed on individual lots, those create a manufactured housing community that is not necessarily a park. And in that case, we cannot simply rely on um, the estate parcel boundary file, which is a bit more complicated. So overall, this was kind of the process that we went through, and there is room to improve the outlier removal part, which we can work on in the future, but we are pretty confident that we have effectively identified the locations of these communities, and there might be some minor error in terms of like which one of these structures belong to the community and which one doesn't belong, which can be fine-tuned if the research has to be done with more rigor. Um, so once this was done, then we were trying to answer some other questions about these communities, like what are the drivers of growth and decline? Because now we had the data sets and we could detect these communities using historical images. So what I did was to go back to 2 decades ago and then try to answer questions like what are the socioeconomic drivers of growth and decline of these communities over time? And what I did was to take the data from US Census Bureau that belonged to the year 2000 and then match it to the images and community shapefiles that we had from those years, and then compare that with the more recent data that belonged to the year 2020 to study what makes these communities grow or decline over time. So we developed some hypotheses like what is the role of total population, or what is the role of different segments like elderly population, and try to answer questions around these socioeconomic drivers. So overall, what we found was growth in population has reduced the share of manufactured housing communities in the housing stock in a neighborhood. And in terms of elderly population, for instance, we find that the growth in elderly population has increased the development of manufactured housing communities. And for each of these hypotheses, we created some potential policy solution, or what these means for investors or economic development efforts or other stakeholders involved in the world of manufactured housing community development. And for instance, when we are talking about the role of elderly population and its role in enhancing or increasing the share of manufactured housing community, it implies that policies should support manufactured housing communities wherever there is a larger share of elderly population. The policy should really support amenities and services that enhance accessibility and elderly quality of life. And for investors, for instance, it means that investors should target regions experiencing a growth in elderly population. Ethnic diversity seems to have a positive role in the growth and the share of manufactured housing communities, and it looks like policies should support housing minority residents in these communities because they go kind of together. And economic development strategies should target manufactured housing communities for inclusive growth. Investment in education and training can uplift these communities. and developers benefit from diversity. Other hypothesis we had was around the role of household size. It looks like larger households have a positive but weak association with growing manufactured housing communities. It looks like smaller households linked to higher education, prime age residents would prefer townhouses, apartments, and condos over manufactured housing communities. And it implies that investors should really target markets with the larger household sizes or other characteristics that support manufactured housing growth as opposed to the smaller household areas. In terms of household income, unemployment, it looks like a stronger economy implies a reduction in the share of manufactured housing communities as people gain more income. They use it to buy more attractive housing units. So in growing economy areas, policies should support other sorts of other sorts of affordable housing solution like mixed income developments and protect existing affordable housing units. And overall, it looks like areas with increasing household income may not be the best investment opportunity in manufactured housing communities. In terms of unemployment rate, the results kind of support the role of the income of these households. For instance, policies should create incentives to maintain the attractiveness of manufactured housing communities for a broader range of residents, as a stronger employment might drive residents toward other housing options. Manufactured housing communities investors should focus on enhancing the value proposition of their communities so they can protect their properties. And we also tested the results on poverty, the rental housing costs. It looks like areas with a high percentage of people living below the poverty line have seen growth in manufactured housing communities, which implies that policies should support manufactured housing communities in high poverty areas. And economic development should improve financial stability, reduce reliance in manufactured housing communities as a sole housing option. And areas with lower income and minority populations have a stronger than average demand for manufactured housing communities. In terms of rental cost, it looks like as traditional housing market prices increase, making home ownership less affordable, more people turn to manufactured homes as a more affordable home ownership option. And as the share of renters increases, the growth in manufactured housing communities tend to decline. It looks like people who are seeking ownership use manufactured housing as a vehicle to grow and build equity and become a homeowner. So therefore, it's important for housing policy to address affordability across all housing types, not just limited to manufactured housing communities. And for developers, our findings suggest that there is an opportunities in areas with a rising homeownership cost as demand for affordable alternatives may increase. And areas with higher housing construction seem to be seeing an increase in manufactured housing communities. Therefore, for developers and investors, it means that they have to become closer to areas that have a higher rate of construction because there is more probability that there is more demand for manufactured housing communities in those areas. And finally, urban designations seem to have a positive role. Manufactured housing communities closer to urban centers or with improved infrastructure are more likely to grow. And policymakers should consider strategies that enhance urban characteristics in areas targeted for manufactured housing community development or with declining manufactured housing communities. For instance, zoning reforms or investment in urban infrastructure and incentive for urban development. So this is kind of an overview of what we did in this two-part research. As a result of this work, we co-authored two different publications. The first one was focused on our methodology for detecting and mapping manufactured housing communities in the US. which is right now in review in the Journal of Scientific Data. The second manuscript was focused on our analysis of the drivers in growth and decline in manufactured housing communities, which is in review in the Journal of Housing Policy Debates. So that said, this is what we did over the last year, and I hope our results will be used by other researchers and stakeholders in this area to inform what they are doing. And if you have any questions or comments, feel free to let us know.
Great. Thank you so much, Armin. We really appreciate it. I have a 2:26 on my watch. Why don't we go ahead and move to the next presentation? We can populate questions for Dr. Yegane in the chat, and we can go ahead and answer those with the time that we have left after the second presentation. Is that okay with you, Armin?
Of course, yeah.
All right, fantastic. Go for it, Lisa.
All right, thanks, Michael. Hello, everybody. I have today from Iowa State University Extension Outreach, Chris Seeger with me, and I'm Lisa Bates, as I was introduced before. And in CED right now at Iowa State, we're really looking at what's the potential role for artificial intelligence in the room of community development, and through the lens of making sure that we're looking at data for more resilient communities. So I'm going to just start off today telling you a little bit about where we're at. At CED, we're lucky to have a data team. We're lucky to have the Indicators program, which has developed many resources, reports, publications, tools. We have training in data literacy. We have training in GIS. So this is really a program that focuses on the data for Iowa and how to access that data, how to make data meaningful to our end users, local, regional, and state level. So one of those areas is I think one of our greatest importance is our data for decision makers. And this is all counties, all communities, and extension regions, our state government, all each have their own crafted data for decision reports, and they're designed to cover very specific areas and topics within community development. Again, these are static reports that are really designed to bring together important data that can cover specific issues. And some of those include a county profile. We again have the city. We have a housing profile. There's a health profile, and soon there's going to be a youth and family profile as well. Again, one of our main areas includes the housing DDM. So this is one kind of look at what housing DDMs might, and our other DDMs might take a look at. And again, it's really crafting those indicators that can help inform a community on the status of their existing housing, also who lives in their community, and start to make meaningful decisions. Also within the Indicators program, we have other types of reports and analysis. We have such things as the retail trade analysis. We have our AgMark commodity reports with one of our teams in the food safety and food systems group that looks at those commodities in the state. We also have the IGFI, which is the Iowa Government Finance Initiative. It really looks at local government finance, community, and economic development issues. And we have various other publications and reports that really show data trends, analysis for various data topics across the state of Iowa. We not only use this within our Indicators program, but we also use data and look to attach and integrate the data team's work into other areas of our CED unit. Some of those include within our housing program. So our data for decision maker housing profile is really great with that, but we also utilize other indicators to help inform a community on their housing issues. Grant writing programs, our leadership program, within planning and zoning, even in arts and engagement. And we're looking to continue to expand and utilize that. That data helps within any kind of area within our state to help make more resilient communities. So how did we get to AI and utilizing AI? Well, our first starting point was that we were awarded a presidential strategic funding, which really helped to understand where the indicators can go into the future. Increasingly, we find our partners, collaborators, stakeholders across all different kinds of entities are looking at more informed decision making. But that's derived from some existing but accessible and meaningful data. And how do you know that it is accurate data is an issue that we try to become a resource for. So our Presidential Strategic Funding Award really aims to utilize data sources and visualization of those data information into the next generation of interactive formats, visual formats, to help create deeper understanding, more effective decision-making at the local level. We also are looking to increase our accessibility of our data indicators. So how do you make it easier for an end user to identify, locate the information they're looking for, but again, make sure that they are looking at the most accurate information, most local information that's accessible to them. And so that's where we really are opening our eyes to what AI can do within our community development unit. And I'm going to turn this over to Chris.
All right, thank you, Lisa. Actually, one of the first questions you should be asking yourself is, what is a landscape architect doing working with community data and leading a research unit and stuff like that? And it comes down to our team values data in the decision making as professionals, and we have worked to strengthen our skills to become better at working with data, but also sharing that data with the public and helping them learn about how they could better use their data. And one of the projects that we started out several years ago was this data science for the public good. This was a joint project with Virginia Tech, Oregon State, and is USDA funded. And we started this in 2020. And we've been able to, it was a partnership the first year with the 3 states, and then we've continued on since then on our own, and have been able to put together a program now for 5 years. We had 59 students already participate, and we've done 24 projects. And in these projects, this happens during the summer, our students take on possibly new technologies or new approaches to doing things, and 2, how can they apply data to actually help rural Iowa or communities in Iowa, organizations in Iowa, utilize that data to help make decisions. And so you can see why the USDA was initially interested in this, of course, through extension and outreach opportunities. But it's been a great opportunity for us to really investigate what can we do, how can we best communicate data. And so with the AI, with the President's strategic plan and this happening at the same time, we've kind of merged a few pieces together. And I'd like to take you through a few of the things we've done involving housing and AI. Next slide. So as we started out, the big picture idea of what we were looking at came down to 4 main things. We knew because of our background in data that we'd have to work with large language models. We would also need a strong knowledge base of information dealing with housing finance, the policies, the needs, the federal housing rules, urban development, all those policy and design type components. We also need to work with data, and this would include things such as the satellite imagery, which was mentioned in the last presentation, to help us understand where the populations were located. But then also just as important is how we access the data and how the users might interface with that data from a technology standpoint, but also from a data literacy standpoint. Next slide. So I won't read through this whole definition for you for defining AI, but you can read this if you want later, come back to the slides. But for the most part, this is how we are contextualizing AI and working from it. Very important to note, I mean, there's many different groups building different types of AI models and tools. And the word generative AI shows up quite a bit. And, you know, you could be building pictures or having it make a song for you or write code. I actually do use AI to write a lot of my code when I'm stumped on something. I want to see an alternative way of doing it, and it lets me think about a different process. But what we're finding is all those tools that exist also leave behind a little bit of a shell or a black box to how they work that we can adapt and go and look into and see how it was working and populate it with our own data. So we're also using the structure of AI to generate our own information. Next slide. And so the question that comes to mind right away is, why use AI for housing or doing this work in data? And part of it for us is it's hard for people to get access to data at times and be able to understand it. Even for us at times, going to Census Bureau's website like this, if you're doing it regularly, it's great. But if you're just using this once a month or once every few months to write grants and do a few reports, this can be really difficult. And so can AI help us expand that better, make it easier for the clients that we work with be able to get access to their data? Of course, our data for decision makers is also doing that same thing. It's just in a different manner. What else can we do to make that more interactive as a data component? Next slide. So as great as AI sounds, there's many barriers. And so I want to take you through this. I did this with ChatGPT just earlier this week. I asked it this is the question I asked it. What are the housing characteristics from the 2022 ACS 5-year census for Boone County, Iowa? Now, I was pretty specific in what I was asking for, more than I would expect a client would right away. And it brought back to me, it gave me a list of, hey, all the different characteristics are available. It gave me a nice list of what they would be, what they cover. But for me, that wasn't the answer I was looking for. And so from their list, I clarified that I wanted the home value in Boone County, Iowa. And then it gives me some more information about the home values, the breakdowns, and the metadata on that, which is really nice as well. And after the third refinement of the question, I got it to spit out this verbal or this response, this written response, which reads pretty well. But as good as that is, you do have to look what I have circled here. The ChatGPT can make mistakes. And that's very true. We need to recognize that. And the problem I have, though, is as long as it's able to make lots of mistakes, which I usually find quite a few mistakes in it, then we got to be careful how we use the tool. And part of that is how we build the model and what we give it for information to use to try and limit it from making mistakes. A lot of these tools are made to do everything. We actually only need to do a few things. Next slide. Well, this is just a slide showing, again, some of the information within the data literacy. I think they're getting better on these different tools and providing this, but this is one of the areas we're really looking at. And I should really call it data literacy. It's more contextual information that goes with the data. So people can really understand where it came from and how it fits into what they're doing. Next slide. So jumping back to our 2023 DSPG, what we did in that one is much like the previous presentation, which I really appreciate because we were using some similar things, but we also went out and field tested. We took a program called Fulcrum on iPhones and went and took pictures of all these dotted communities you see here and filled out a form. But then we also started to use, we used the Google API. We didn't get millions of photos. We got lucky if we got a couple thousand. But we used the Google Maps API to take pictures of the house, and we were looking at the facades. And in this initial test, we're looking at rain gutters, if there's trees planted in front, was there a walkway up to the front door, or was the front door recognizable, and things like that. And so we started to do some testing and understanding what tools within AI and the access to AI software we would have available to make these decisions, as well as storage. Next slide. And so through all of this, we kept working on utilizing large language models, expanded more and more testing. The DSPG students were looking at different ways to test. When we were in the field, we actually ran into a lot of people in the community asking us what we were doing and had good visits with them to hear their concerns about the things they wish we could be using and mapping and helping communicate what improvements were necessary in their community. And so as we work through this, we're talking about how we want to enable our data-driven decisions to help make communities more resilient, and then starting to make these complex data sets in general more accessible to our stakeholders. Next slide. Jumping ahead to the most recent DSPG this summer, our students got a lot more into the nitty-gritty of using DSPG and finding out that unless we're willing to pay a bunch of money, you can't run your models except during the late hours of the night, and what those fees are and the restrictions on that. And so it's fun to do these things, but there's costs to being able to run and do high profile AI. And these are some of the experiments that they were doing. In this case, they had done some stuff where working almost in a playground situation here too, asked it some questions, but they're really interested in, once you have the data that is the response, as we have a list here of 5 counties, we now want you to start mapping it and visualizing the results of the data, not just a textual list. We want things visualized in certain ways, and that's what they experimented with here. Next slide. I'll just go through this quick. All of our groups had many different things that they're exploring and lots of flow charts, and there's just so many little details you have to check off and understand how it's going to work if you're going to build a robust AI to use with the public. It's one thing to use the AI in-house if you're just doing the research and you're using it as an add-on tool, but we're trying to look at how we can use AI to help answer everyday questions in communities. And next slide's good. And we're also dreaming big, where we'd like to go, big ideas. We're starting with the level on the bottom here with visual responses to queries, as you saw from our study this summer. We'll be then working up to doing some simple analytics with that data, maybe 1 or 2 metrics at the same time. Then looking forward, working more with analytics that deal with relationships and identifying trends. And finally, ultimately, being able to predict, if you can bring live data in, can you predict how some things might happen or where there's areas of concern? Next slide. Most recently, we have done a lot more exploration of additional AI existing tools as more software has made their playgrounds available. These have been very valuable for us to test out the way we ask questions, and to start to think about what's that user interface going to look like, and how we have to package information to send it to the AI from the user. Yeah, there we go. Okay, yeah, so our other big thing right now is we're using Azure in-house because that's what the university has, works with Microsoft. So we have the Azure system. We also use Tableau on the user interface side. So we're starting to work to blend these things together to see if it's going to be the right fit for what we need. But at the same time that's going on, of course, we're having to keep our eyes on the fact there's other technologies. OpenAI, Llama, LangChain are just a few of the different ones that are out there that we want to look at, because it's definitely not a one tool will do everything for you type of solution. And then our future applications, we're ideally hoping to have AI help us find patterns from other data sets. Our natural language processing, while there's libraries that exist, do they know how to interpret the types of questions that might be related to community development? So we're having to do some of those tests. We'll have to track what is asked, what the results are, to see if it is in line with what we might have provided as a response. And then obviously AI can spill information very fast, but is that information understandable and accurate for the end user to use? So just like it's really no different than going out and giving a presentation and extension to a community and then doing an evaluation afterwards to see if the client understood what message you were trying to convey and what things you can do to improve it the next time that you give that presentation. I think that might be the last slide. Yeah.
Great. Thank you so much, guys. This is pretty incredible. Very interesting use of technology in both presentations. I feel like my dad asking me back in the 80s to program his VCR. It looks like we've gone well beyond doing that now. So I'm going to have to find my person that can help me program this VCR, it looks like. Thank you very much. We do have several questions in the chat. I think the first question was asked fairly early, so I believe this is to Armin. The question says, my question is how is housing and community development decreasing the unemployment rate and poverty rate? This is a very general question, but you had some specific results, I think, from your research regarding unemployment and poverty rate. Would you like to comment on that?
Yeah, so what I was trying to say was the impact of unemployment and poverty on manufactured housing. So we find that in areas that there is a decline in improvement or decline in economic a decline in economic activity or employment, there is an increase in the share of manufactured housing communities because people refer to them as more affordable solutions. So for investors, those areas are a good target, a good opportunity. And so that was the idea. So I think that kind of answers that question.
Thank you for that. We have another question, and this, I believe, is to Lisa and Chris. Deanne is asking, what is the estimated cost of the work that you're doing?
So that's actually something we are trying to figure out ourselves. Okay. We fortunately have dollars to invest in this right now to investigate. So we have a set amount of money, but part of that job that we have to do right now is to find out, what does it cost to build this? What does it cost to, even if we had all the data we needed today, what's the cost to truly run a system that can accomplish what we want to do? So we're investigating. I mean, and just so you guys know, you can buy in, there's multiple tiers of levels in the Azure system that you can subscribe to or pay for. And part of it's a capacity issue, and part of it is a capability issue. So determining what capabilities is what we're looking at right now. And then we'll have to look at raising those to different tiers based upon how much use. In a success, here's the thing. If we're truly successful at doing what we envision doing, then our capacity should be high and our expense should be high, right? But if it's all going to be based on that capacity of use and what tier we fit into. So we're looking at that. But again, every tool has a different model. Azure's is fairly straightforward, but just when we think we've got something figured out, we realize, oh, you have to turn that on too. And that's another $50 a month or like that.
Thank you for that. We have several other questions, and so I want to make sure that we get through them. Sydney says, thank you for this presentation. It's incredibly informative. And then they ask, how are y'all, and that's, I appreciate the use of y'all, how are y'all mitigating systemic biases within the data set of the AI platform that you're using?
I can answer that to a degree.
Okay, go for it.
Part of it, we have to recognize right away. Bias data coming in, we can't do really anything about that initially. So we're going to have that. We have to recognize that. That's one level of looking at the bias. But I think the question maybe you're asking a bit about is our selection of data or how the AI is developed. That's going to come back down to the testing. We've got to be knowing that when we're doing the encoding, would be unit testing, things like that. We've got to do the testing to actually try and ask it questions in which it could provide a biased answer and recognize those first. That's the first level. It's basically try to break the system, right? And you've got to do that and find out, well, what is that structure? Because you mentioned systematic. Some of that system things in there, that's part of the design. And that's what we have to look for and try different ways. But then also having a broad set of, once we mature these, having a broad set of people ask different questions while it's still in our testing playground so we can work some of those things out. The other data, we got to go back to census and places like that to ask about biases.
Thank you for that. Here's another question. It's a little out of my league, but I'll throw it out there and then you guys can fight over who wants to answer it. It says, may I know the way to segment the boundary of building from the Google map?
Yeah, so that kind of my question. So it is, so there are many different ways of doing that, but probably one of the straightforward ways is to use the ArcGIS deep learning model that's called building footprint extraction. So that's not inside ArcGIS Pro, but you have to install it. Just Google building footprint extraction. Then there are some videos you can find how to install that on ArcGIS Pro, and then you go from there. But there are also other ways that researchers are developing to better distinguish the building's boundaries from the environment and remove the shadows and more accurate ways of doing this. This is a growing field, and there is still progress being made. But again, building footprint extraction algorithm by ArcGIS Pro, that's, I think, the best first step.
Thank you for that. Glad to know that AI has its own lingo here and acronyms. I thought extension was the only one that loved acronyms. This question is, may I know which model had the best result on the MHCs?
Yeah, so many of them have comparable performance metrics, but the one I used was MobileNet because it was processing the images faster than others. So that's why I choose them over the other ones.
Okay. We still have about 9 minutes. Happy to take questions in the chat. Or if you're a gregarious type, I believe that you have the capacity of raising your hand and coming on video and asking a question verbally as well. Any remaining questions? Not hearing any. Thank you so much to our speakers today. We really, really appreciate it. If you look in the chat, there's several people thanking you for your incredible presentations. We certainly appreciate it. The recording will be sent out. It'll be available on the NCR-CRD website. You'll also be getting a survey from us. Yep, that Shelley just put all that in the chat. Thank you, Shelley. We appreciate you guys spending time with us today. We look forward to seeing you again on November 22nd when we talk about mental health, another major issue here in the North Central region. So thanks again for joining us today and have a great rest of your week. Take care.